Hey everyone, I'm Joel. Before we dive into today's video, I want to make sure that you are all set up with the basics. If you haven't already, please check out the following two videos on installing Ubuntu 20.04 in VirtualBox and installing ROS Noetic, as they are crucial prerequisites for what we'll be covering today. You may find many great tutorials on these two topics on YouTube or other platforms. I'll also include some recommended links in the description below. Once you complete these steps, you'll be ready for today's video. I'll guide you through the process of installing the necessary packages and setting up the simulation environment for the NavRover project. So let's get started. Okay, so now let's get into the process of installing the necessary packages. So the first package that we have to install is ROS control. And this is crucial for the workarounds which are implemented here. So to install this package, go down to this website, which I'll be adding in the description below. Copy this command. Copy. Open the terminal. Paste. Now change this segment, that is $ROS distro, to Noetic. Noetic. Same goes for here as well. Press enter. Type your password. Press yes. Okay, good. So that's done. And the next package which we have to install is the twist teleop keyboard. This is used to control the rover in the simulation environment. So same thing as before, copy this command, include this, paste this, move the $ROS distro to the version of the ROS which I'm using now, which is Noetic. Okay, good. So that's done. So the next package which you're going to install is the mapping package. In this case, I've implemented G mapping. So to implement that, you have to type the command sudo apt install ROS Noetic slam G mapping. Press yes. Okay. So that's also done. Great. So and the last package we have to install is the navigation step, as it is critical for the autonomous navigation part of the rover. So to carry out that, we will type out this command sudo apt get install ROS Noetic navigation. Install this. Okay, so that's also done. So we have installed all the necessary packages for this project. Now, next thing that you have to do is go to the project repo that I have hosted in the GitHub page. Copy this, clone this repo to your home folder, and after that, do git clone. Paste. Now you will clone the entire workspace. Now, if you see the home directory, you will see that NavRover is now present. Great. So that's done. So okay, so now I'll be talking about two main worlds which are built for this project. One is the teleop.world and the other is nights and weekends. So these are two main fully made worlds for this project. So if you want to switch between them, you can do so by commenting one and uncommenting the other. So in this case, I have commented the nights and weekends world line and uncommented the teleop.world line. But apart from these two worlds, I've also made few basic worlds as well. One is the first dot world and the other is test dot world. So if you're also interested, you can try them out by replacing the dot world with out of them. Now, for example, I can try showing you the teleop dot world. I'm now running the launch file. Now, this can take some time for it to load up due to the amount of meshes and elements available into this world. So the load up time can vary based upon your system's capabilities and functions. So this is the world with the rover in it. I've also added some obstacles for testing out the rover's rocker capabilities. Now let's try driving the rover. Then we can do so by running the teleoptus package. Okay, so after you run the package, uh, shift the terminal to the side so that you can view both the world and the terminal at the same time because the terminal has to be active for the rover to be controlled. So if you want to control the rover, they have specifically stated the keys which has all been predefined by this package. And we can use those keys to drive the rover around. Now you might find the rover's movement might be a little choppy because I'm running this in a VM machine. But if you were to run this in a dual boot configuration or in a primary boot configuration, you might find much more better experience which I'm facing now. So as you can see, the rover moves the way it is intended. Okay, so now I'll be showing you the rover's mapping capability. So I've implemented mapping via the gmapping package. So I will show you the launch file for that just now. So in the launch file, uh, is known as 2D underscore mapping dot launch. So by running this launch file, this will execute both the world and the RVS to view the mapping that is done by the rover. But in this case, I've already made a map called Nights and Weekends Season 5. So for this showcasing of the video, I'll be uh, converting this to teleop.world. Now let's run the 2D mapping package, 2D mapping launch file. As you can see that the mapping has started. Okay, so I also implemented camera. This is a map from the rover's perspective. Now, if you want to continue with the mapping process, let's try by controlling the rover. As you can see that as the rover moves, the data that it obtains from the sensors is utilized to update the map of its surroundings. Now, if I were to save the map, I'll open the new terminal and I'll run this command. ROS run map server map underscore saver f and with the name of the map. Now, but in actual case, you have to drive the rover around to create the entire map of the environment. But in this case of show in this method of saving the map, I just save it as such. Just you can see that the occupancy data and the PGM dot and the YAML file has been created. Now I can close both these terminals. Now, if you want to view the saved map, it's around the workspace. So this is the map that the rover has made from this current point. But if you were to drive the rover around, you will have created the entire arena. Okay, so now I'll show you the rover's navigation capabilities. I have carried this out using the ROS navigation stack, and I've written a package known as NavRover underscore navigation to carry this out. So now let's look into that. We go to the workspace, SRC, navigation. So in this, there are several folders and several CMake lists and package.xml file. And if you open the maps file, I've already created the nights and weekends world based map. So that is what you see here. Apart from this, I've also created a map on a museum. So this is one of the general worlds that can be obtained in Gazebo. And this is from a normal building which I made from the building editor in Gazebo. So today I will show you like how to carry out the navigation in this world, in the nights and weekends world, as this is the default world which the rover rolls in. Okay, so now let's open the Gazebo using the gazebo.launch command. Close it. As you can see, the rover has been launched successfully, and so has the nights and weekends world. So now let's carry out the navigation part. So I've combined the move base, aim sail, and the map loading into a single launch file, which I'll show you right here. So if I open, these are all the configs. That is, all the parameters can be tuned by altering these config files. There are several launch files. I have combined all of them into a single launch file known as navigation.launch. So this launches the RS, launches the aim save plus map loader. So this carries out the localization as well as it loads the stored map, and this carries out the navigation spot. So I've written two move base. One is on trajectory planner, the other is on DWA. So I have also written the parameters for DW as well. They are given as such: DW underscore base local params, DW underscore local params, and so on. So based upon your interest, you can switch them out as per your needs. So, but in this video, I'll be just showing you the navigation using the trajectory planner. Now, let's also turn on the teleup keyboard, which can be used to control the rover to localize itself on the map. Okay, so after the map is loaded, you should see something like this. But sometimes the coloring can change here or there, but still the overall map and the rover should look something like this. So all these red arrows which you see here are all the pose estimates that is done by the AMCL node. That is known as adaptive Monte Carlo localization. So what this does is that in a simpler explanation, if I were to say is that it generates random poses of the rover, and as it obtains more and more sensory readings, it removes those poses which it doesn't seem fit, and it selects those which are, and it builds on top of that. So that is what we're going to do here. We'll first give the initial pose here. So that is done by clicking on 2D pose estimate, and we point to direction where the rover is currently being spawned in. So that is in this direction. So as you can see that the entire arrows are now pointing in this direction. So now let's now try to localize the rover. So this can be done by controlling the rover. So let me start controlling it. As you can see that majority of the arrows are now being concentrated to the rover itself rather than being spread out. As it obtains more and more sensory readings, it is getting a clearer picture of where it is. Just keep the rover at a certain location. You can keep it anywhere like, but just for the sake of a little challenge, I'm keeping it somewhere around here. Just keep it around here. Okay, so now the fun starts. So to carry out the navigation part, click on this known as 2D nav goal, and you point to the direction where the rover should go. So this will create the entire path or the trajectory to where the rover should go and where it should arrive at its goal destination. As you can see, the rover is now turning and is carrying out the entire task autonomously. That is, I'm not controlling the stuff by teleoperation. You can also see the camera feed over here. And you can also see the gazebo simulation as well. You can see that sometimes rover is a bit conservative or hesitative when it reaches certain parts of this arena. And you can try to improve on this parameters based on uh, the sensitivity factors and everything. And you can change them in the config folders which I've shared in the repo. So as you can see, the rover is now reaching its destination, albeit by having some difficulty in this area. But this can be improved by altering the parameters such that it balances the between the safety as well as reaching its desired objectives. But at the end, it reached the goal. So that does deserve a celebration.